Hello, and welcome to today's Lunchtime Festival of Ideas event, which is the science of sleeping and dreaming a foggy field. My name's Tom Stoneham, and I'm a professor of philosophy here at the University of York. And I'm delighted to introduce our colleague from City College. And I'll explain a little bit more about the relationship between York and City College in a minute. But first of all, a few technical notes. If you're watching live, you can ask questions using the Q&A button at the bottom of your screen. This is available throughout the event, though we'll take questions at the end, but you can ask your questions when they occur to you, and I will select from those. Should you have any technical issues, the original link you were sent will allow you to re-enter the webinar. So if you lose your Wi-Fi connection or something, you can re-enter with the same link. Please also remember that today's event is being recorded, so you will be able to watch again. Subtitles are available. And to turn these on or off, use the CC, it's in closed captions, live transcript button at the bottom of your screen. As I mentioned before, the event today is hosted with City College, University of York, Europe campus. The University of York and City College, which is based in Thessaloniki in Greece, have agreed a major strategic partnership. City College, University of York campus is a flagship initiative, and the campus status reflects equivalency in teaching, quality standards, learning resources, and student experience across the two institutions. The partnership sees York awarding degrees across various subjects, including English studies, psychology, business administration and economics, and computer science. And today, we're absolutely delighted to welcome Aristea Ladas, who's a researcher at the Neuroscience Research Centre at City College and is a research associate at the Southeast European Research Centre, both in the Cognitive Neuroscience Research Cluster. Aristea is going to talk to us about her fascinating research into the mystery of sleep and dreaming. She tells me this isn't her primary research area, but this is her passion. She will delve into the phenomenon of dreaming from a psychoanalytic and from a cognitive neuroscientific perspective, exploring how dreaming connects to consciousness. So please allow me to hand over to Aristea to share her exciting research with us today.
Good afternoon, everyone. Thank you, Tom, for the wonderful introduction. I'm Aristea. I'm teaching at City College and a proud member of the Neuroscience Research group at City College and the Southeast European Research Centre, as Tom told you. And as you have already been informed, it's not my expertise, sleeping, dreaming, and consciousness, but indeed, it is my passion. And hopefully, I will be able to transmit at least some of my passion to you today. Feel free to ask any questions in the Q&A room, and if I can, I will be more than happy to answer or to provide you with even more questions to start wondering. So let's begin the presentation, the talk of today about sleeping, dreaming, and consciousness. I will share my screen now with you. Okay, so when sleeping was starting to be investigated from a neuroscientific perspective, we didn't know much about that. We could theorize about that. I mean, ancient Greek philosophers have long theorized about what is sleeping, and especially what is dreaming. However, as genuine scientists, we always need the evidence to show us the way. So we started wondering, why do we sleep? Is it necessary to sleep? Sleep restriction studies have shown that if we continuously sleep for less than 6 to 7 hours per day, our immune system demolishes which doubles the risk for developing cancer. The chances of developing a neurodegenerative disorder such as Alzheimer's dementia increase. The blood sugar levels are profoundly disrupted, reaching a pre-diabetic level within about 2 to 3 days of complete sleep restriction. Fat is accumulated throughout the body, which increases coronary artery blocking, leading to cardiovascular diseases, heart failure, stroke, and infertility. It contributes to major psychiatric conditions such as bipolar disorder, depression, anxiety, and suicidality. And generally, reducing sleep means that you are reducing your lifespan. So it seems that indeed sleep is valuable both physically and psychologically. But why is that? What's happening while we are asleep that is so valuable to our organism? So we have certain clusters of theories, we could say. We have the restoration theories supporting that sleep is needed to restore homeostasis, because during waking time, that homeostasis is disturbed from our waking experiences, and the brain has an innate need to restore that homeostasis throughout the body. The circadian theories assume that sleep is the result of an internal timing mechanism, and that mechanism evolved to protect us from the dangers of the night, because assumingly the most dangerous predators in nature go out to hunt at night. So that's an evolutionary perspective of sleep, we could say. And the plasticity consolidating theories, which can be combined to the recuperation theories, support that sleep facilitates learning and memory consolidation, as in it strengthens the newly developed neuronal connections that are formed, because when you learn something new, or when you experience something and you record it in your memory, that is translated in neuronal connections in your brain. This is the learning that we do. These are the memories that we hold. It's all connections between neurons. Now, excuse me. Now, these neurons, as supported by these kinds of theories, these neuronal networks, I would say, need consolidation, which happens during the night and while dreaming, actually, to get stronger, so that at any point needed, you can access them during wake time. Without that consolidation, that learning and those memories are recorded in your memory. However, you cannot access them consciously. So it seems from these theories that we can predict several things that we can test, because, science is all about testing our predictions. So according to the recuperation and restoration theories, we can predict that long periods of wakefulness will result in disturbances, and these will get worse as deprivation continues. And after deprivation, much of the missed sleep will be regained, and especially REM kind of sleep, which we will describe later on, because it seems that most of the restoration happens during the REM state. Adding the plasticity theories come to add another similar prediction, according to which sleep deprivation will result in memory and learning deficiencies. So what does the research actually indicate regarding these predictions? First of all, before reviewing the literature, we have to keep in mind that it's in sleep research and sleep deprivation studies, it is very difficult to separate the effects of the stressors that are used to keep someone or an animal awake from the effects of loss of sleep. Also, because we tend to be very poor judges of the effects of sleep deprivation on our performance, it seems that we are not that aware of the detrimental effects that sleep deprivation has on our performance if someone asks us to describe them. So we most possibly need to use more objective measures of performance. By using those measures, it seems that even the smallest amount of sleep deprivation influences concentration. A series of studies run by David Dengis, for example, and their colleagues, has shown that one night of sleep deprivation in humans leads to a 400% increase of concentration lapses the next day. And when we say concentration lapses, we mean that these participants were asked to respond to a computer task by pressing a specific button when they detected the target, whichever that target was on the screen, say that it was an asterisk. So they were asked whenever the asterisk appeared to press the button. Before sleep deprivation, participants did almost perfectly in detecting the target. After one night of sleep deprivation, they lost most of the trials with the target. They didn't even realize that the target appeared, that is. With 3 to 4 hours of deprivation in one night, sleepiness increases. We experience disturbances on written tests of mood, and we show a poor performance on tests of vigilance. With 2 to 3 days of continuous deprivation, we experience microsleeps, which is, in a sense, small naps of 2 to 3 seconds. But it's not just naps, it's a complete loss of conscious awareness for those 2 or 3 seconds. So imagine that experiencing a microsleep while driving is most usually fatal. For example, in the US, every 1 minute, a car crash happens due to microsleep. Similarly, with chronic sleep deprivation, meaning to sleep less than 7 hours per day, you experience microsleeps. Although there is little effect of sleep deprivation on logical deduction, critical thinking ability, physical strength, and motor performance, the largest effect of sleep deprivation takes place on higher order brain functions, such as executive functioning, and especially in assimilating changing information, in updating plans and strategies. Innovative, lateral, insightful thinking is negatively influenced, as well as reference memory, and of course, cognitive and behavioral and emotional inhibition. Because inhibition, which is one of the most important higher order functions of the brain, is very little while sleeping, and especially during REM dreaming, which is most interesting, and it must have a use. However, if you experience this disinhibition while awake, then you will certainly experience issues. But besides the cognitive effects of sleep deprivation, emotions are also influenced very much. So it seems that we experience emotional irrationality when we are sleep deprived, meaning that one night of sleep deprivation amplifies the activation of the amygdala, a certain brain structure, by 60%. That brain structure is responsible for triggering very strong emotions, the ones involved in the fight or flight response, such as anger, rage, or intense fear. And imagine that that structure fires by 60% more with one night of sleep deprivation. This, paired with the fact that the brain's ability to inhibit such emotional activity decreases dramatically with one night of sleep deprivation, maybe you can now explain why you snapped out to your partner this morning with no obvious explanation. So it seems that in humans, sleep deprivation can have up to devastating cognitive and emotional effects. As for animals, experiments with rats using this kind of a device, which turned every time they detected in the electroencephalogram that the rat was going to sleep, this roundabout just turned to wake them up. And if they didn't wake up, they would be thrown in the water, the poor animals. But this provided us with a valuable insight into sleep deprivation, because unfortunately, these rats tend to die after several days, about 5 to 7 days of complete sleep deprivation. and post-mortem studies revealed that these animals experienced extreme stress during the sleep deprivation trials, and this resulted in complete system failure, we could say. So it seems that on the one hand, sleep is valuable physically and psychologically. So on the other hand, we must have evolved some kind of mechanism to go to sleep if sleep is so valuable. And if that was a question, we would say yes. Actually, we have evolved certain kinds of mechanisms to fall to sleep. Otherwise, I don't think that many of us would want to go to sleep. So first, there are two main factors creating the urge to sleep in humans. That, first of all, is we have the circadian sleep cycles. The circadian rhythms, meaning about a day, about 25 hours of a cycle, actually, from being awake to falling asleep. Virtually all physiological, biochemical, and biological, psychological processes, so some circadian rhythmicity. The brain structure controlling that circadian rhythmicity is called the suprachiasmatic nucleus, which very wisely and not by chance is placed right behind the nose, in the middle of the eyes, right behind the nose, because there we have the optic nerves leaving the eyes and crossing each other with visual information to take them back to our visual portion of the brain. So that's called the crossing of the optic nerves, is called the optic chiasm. Right behind that, we have the brain structure controlling our circadian rhythms. And that's because that brain structure samples light signals from the optic nerves to tell the body that now it's getting dark, you have to go to sleep. In addition to sampling light, it also controls temperature, metabolism, hormone release, such as the vampire hormone, which sometimes melatonin is called, where the suprachiasmatic nucleus will give the order to the pineal gland to secrete, to signal the body that it's getting dark, so you have to fall asleep. If you transplant the suprachiasmatic nucleus, the sleep-wake cycle is also transplanted. Now, how does that brain structure know, however, that after about 16 to 17 hours of being awake, you then need to go to sleep? It uses certain cues from the environment, such as light and other reliably repeating cues from the environment, such as food received in certain hours, or exercise if you repeat it every day, social interactions, and so forth. Any kind of signal from the environment that is repeated every day, so that you can, your internal clock can realize that there have been so many hours that you have been awake, so now you need to fall asleep. If you remove those cues, which are called the Zeitgebers, you will see the circadian sleep-wake cycle still? Well, it seems that, surprisingly, yes, you will. Which means that it's not only the circadian cycle that influences whether you will feel the urge to fall asleep or not, but there must be some other additional factor influencing your motive to go to sleep. That second factor is called sleep pressure. Actually, while awake, adenosine accumulates in the body, in your cells, which is part of our cells, actually. And when it reaches its peak, you feel an uncontrollable urge to fall asleep. Of course, you can use at that point several stimulants to control that urge, because, for example, you need to pull an all-nighter to study about something. So, for example, caffeine. Now, caffeine blocks adenosine receptors in the brain, meaning that it does not allow that accumulated adenosine to enter the neurons, the recepting neurons, so that to experience the effect, the tiredness effect of adenosine. As soon as the caffeine's effect goes away, then adenosine enters the receiving neurons and you feel that you are so tired that you cannot do anything different than to go to sleep. Even while under the effect of caffeine, still adenosine accumulates in your brain, meaning that when the effect of caffeine draws off, you will feel even more tired than you felt when you started consuming caffeine to stay awake. And that's called the caffeine crash, which is one of the part of the evidence supporting the existence of the factor called sleep pressure. So we have the circadian cycles and we have the sleep pressure with adenosine to signal the body and the brain that we need to fall asleep because, as we tried to show earlier, sleep seems to be very important for us. How do we know? We said that humans are very poor judges of the effects of sleep deprivation on our own performance. Well, actually, in the neuroscientific field, we use the EEG, the EOG, the MEG, the MRI, and similar brain imaging techniques to study sleep. Now, the EEG is the machine where you have some electrodes attached on your scalp, and those detect the electrical activity of your brain, because that's what the language of the brain is. It's electricity and chemistry, actually. Then you have the EOG, which records the eye movements even when eyes are shut. And this is interesting in sleep studies because during one of the stages of sleep, which is the REM stage, you see rapid eye movements. That's where the name comes from also. We have the MEG, which detects loss of activity in neck muscles during some sleep stages. And that happens, we assume, because you need not to act out your dreams. And so if you have that, as we could say, paralysis, muscle paralysis, then you won't be acting out your dreams. And then we have the MRI to detect brain activity while asleep. And this is just an example of the wave patterns that we see while we are asleep from the EEG. So here, it's the state of alert wakefulness. Just before you fall asleep, the alpha waves start to be transmitted more, so your brain electricity starts to change. Just for you to know, we have certain kinds of different waves that the brain produces, such as the infralow, the alpha, the beta, the gamma, the delta, and the theta. So during wakefulness, we usually experience beta waves. We can experience also, when we are mostly alert, we can experience the waves from the gamma band. But when we start falling asleep, alpha waves start to increase, and then these change that can change to beta waves, to theta, and then in deep sleep, at stage 4 of sleep, we experience the delta rhythm, which is the brain electricity waveform of deepest meditation stages, signifying dreamless sleep, or at least sleep that you cannot report your dreams afterwards. It's considered the source of empathy, and it's considered a state where healing and regeneration are stimulated in the brain and in the body. So it seems that deep sleep with delta waves is what's regenerating our brain and body mostly. So we have the 4 stages of sleep, and we go through all these 4 stages during a one-night sleep in forms of cycles. So you begin from wakefulness, and you go from stage 1 to stage 2 to 3 and 4, and then to stage 3, 2, and emerging first stage. Now, the first stage is different than the first stage that you experience when awake. In the emerging first stage of sleep, you now experience the REM state and complete lack of core muscle tone, that's sleep paralysis, to protect you from acting out your dreams. Again, you fall to stage 2, 3, 4, and then rise to stage 3, 2, emergent 1, and continue this cycle in cycles of about 90 minutes until you wake up, hopefully, the next morning and not earlier than that. The peculiarity of the REM sleep stage is what made scientists believe that there must be something really special with that state. During REM sleep, you experience rapid eye movements, of course, as the name suggests, complete loss of core muscle tone, you transmit low amplitude, high frequency EEG waves, increased cerebral and autonomic activity, muscles may twitch, and you also experience clitoral or penile erection, not because of dreams with sexual content, but because this is the physiology of the REM state. Now, the most interesting fact about REM sleep, to my opinion, is that EEG most usually records gamma frequency in the brain while in this state. Now, gamma frequency is the fastest of all brain frequencies. It's actually so fast that it is above the frequency of neuron firing, making scientists wonder how on earth can it be generated, since it does not to be generated from the brain per se. It could be a product of brain synchronization, because during REM sleep there is so much disinhibition of the brain regions and so much communication about between certain brain regions. So maybe the gamma frequency is produced somehow from that synchronization. We also assume that the gamma frequency may modulate perception and consciousness. And it certainly signifies the simultaneous information from different brain areas. 80% of awakenings from REM sleep yield reports of very vivid dreams. External stimuli may be incorporated into dreams experienced during REM. So, for example, maybe someone turns a light on in your room while you're asleep, and maybe you see that a light turning on in your dreams at that moment. A fact is that everyone dreams, whether we remember those dreams or not afterwards. That penile erections are not a result of erotic dreaming, as we said, and that sleepwalking and talking are very less likely to occur while REM dreaming. Actually, it seems that we are dreaming throughout the sleep stages, but these vivid experiences that we tend to call dreams in lay term language are the dreams that we experience during REM. The ones that we experience in deep sleep conditions, such as the fourth stage, are usually not remembered at all. So this made some people wonder whether dreaming is just a byproduct of all this massive brain activation during REM sleep and brain disinhibition at the same time. Truth is, and now we enter the most interesting part, to my opinion, of today's talk, that every night, as a great sleep researcher says, every night we become psychotic, each and every one of us, from the moment we're born until we die. Because during dreaming, we experience visual hallucinations because we see things that are not there. We experience delusions because we believe things that are really far from logic explanations. We get completely disorientated as to where we are, with whom are we, what day is it day or night? We experience what therapists call affective labile, which is actually experiencing very intense emotions. And we also present mostly with amnesia the next day about this whole psychotic experience. This kind of bizarre, hallucinatory, strongly emotional, motoric experience that we call dreams is actually experienced during REM. So it's very sensible to assume what on earth is happening during REM. And there must be something special about REM sleep and state of consciousness, since it's so different from any other kind of sleep state. Well, the brain areas that are right at the left to the green arrow show very much increased activation during REM sleeping, such as the visuospatial areas, the motor cortex, the part of the brain which is responsible for movements, the hippocampus, mainly the structure for autobiographic memory, the amygdala and cingulate cortex, mainly producing emotions and processing intense emotions, and activity in the prefrontal cortex, the part of the brain mainly responsible for control, either that control being emotional or psychological or behavioral. These are mostly disinhibited. So we see that we have huge activation in areas that have to do with dream experiences and deactivation of inhibition. So it seems that the brain is somehow, we could dare to say, left free to create while dreaming. So there might be more to dreams than actually being a byproduct of brain activation. As Auguste Kekulé said, the Nobel Prize winner, let us dream, gentlemen, and then perhaps we shall learn the truth. Because actually he discovered the structure of benzene during a dream. Now, you must all be familiar with the psychoanalytic perspective, because one of the great schools of psychotherapy is the psychoanalytic one. Freud was one of the modern theorists to invest on dream interpretation and to include dream interpretation in the process of psychotherapy, although he believed that dreaming is nothing more but a byproduct of sleeping, and we actually dream, we have that function of dreaming to protect us from waking up due to what we experience during dreaming. And I'll explain right now what we mean. So according to the Freudian theory, our everyday lives are filled with emotions, wishes, urges, and experiences that we actually cannot handle consciously. We repress those to our unconscious because we cannot handle them. And these are called, the conflicts that we experience. These, in the unconscious, are made inaccessible to conscious cognitive activity to protect our ego, as Freud called it. And these they are made inaccessible from the censor, the guardian of our ego, we could say. These are preserved in the unconscious. However, when we're asleep, due to that brain disinhibition, as we know now, but Freud didn't actually know back then, but he very successfully theorized about it, that automatic repression reduces, and then these repressed experiences, wishes, and urges come to the conscious surface, or try to come to the conscious surface. Now, if these were allowed to come to consciousness, we would wake up. Waking up is avoided, however, through the process of dreaming, because dreaming at that point serves a pressure release valve function. So instead of waking up and thinking about these conflicts, you experience them during your dreams, but in an altered form so that you can handle them emotionally. And that is the reason that you remain asleep. So dreaming is in essence the guardian of sleep. Now, dreams, according to Freud, are constituted from the manifest content, what we remember afterwards, and the latent content, the hidden meaning behind the dream that we watched. Now, the work of the unconscious is to transform that psychic material to some kind of material that we can consciously handle. So by censoring, editing, and compromising that psychic material, according to Freud, we have our manifest dream. So there is no psychological work while dreaming. It isn't necessarily just byproduct of maintaining sleep. However, it is very useful in the process of psychoanalysis because it helps the person to gain access to their unconscious conflicts and urges and wishes, which, according to Freud, create any problems that you might experience in awake life. So you use dreaming as a gateway to your unconscious to resolve those conflicts and again regain your psychological health. The activation synthesis hypothesis came after that theory as a modern alternative, supporting that dreams are due to cortex's attempt to make sense of random brain activity because supposedly the brain has an inherent need to make sense of everything. So if you experience certain scenarios while asleep, you have the need to make sense of those scenarios even while asleep, so that those dream-like stories are created. However, according to Carl Jung, dreaming is a phylogenetically older mode of thought. And there is where the interest lies, to my opinion, because as far as I read from certain very interesting studies, indeed, we could see dreaming as a state of proto-consciousness, of the first kind of consciousness that arises as soon as we're born. So according to the review of Hobson, we have a primary consciousness, which is awareness, perception, and emotion. And we have secondary consciousness, which is dependent on language, and it involves self-reflection awareness, abstract thinking ability, metacognition, how do you know that you know, all these kinds of functions. When you're awake, both primary and secondary consciousness are at work. When you're asleep in non-REM deep sleep, awareness is diminished. However, while you're dreaming in an REM state, primary consciousness is active, while secondary consciousness remains inactive. And this is the reason why, for example, you're not aware that you're dreaming while you're dreaming, because you don't have the metacognitive abilities active to realize that. We have certain evidence to support that view of primary and secondary consciousness and lack of secondary consciousness during REM dreaming. And Hobson explains that in the sense that existing neuronal mechanisms must be exposed to experience to fully develop, just like the visual system. As soon as a baby is born, their visual acuity is not perfect. They need to be exposed to visual stimuli so that their visual system is trained to those stimuli. Similarly, brain neuronal networks need to be exposed to experience to form and to strengthen. Since during REM sleeping, we have minimal inhibition throughout the brain, and also the younger someone is, the more REM they experience while asleep, then certainly the REM brain activation is valuable to form the newly developed brain networks that we form as soon as we're born. Because neurons need to be connected to each other to form those networks. Therefore, REM dreaming can be considered a state of proto-consciousness, an initial state of consciousness and awareness that a newborn forms. They are rather equipped with that ability to experience proto-consciousness as soon as they are brought into this world, and that proto-consciousness gets enriched and more enriched by experiences. So their cognitive abilities develop until they reach a point during adolescence where their abstract thinking and metacognitive abilities are fully developed, and so they can then experience their full secondary consciousness. Now, we could go on for hours and hours discussing this. I will try to stay only to the important things. The brain areas that are excitated while we experience secondary consciousness, and they are also active when we are dreaming, but not when we are REM dreaming, actually, when we are lucid dreaming. We also seem to have primary and secondary consciousness. Lucid dreaming is considered as an intermediate state between awake and dreaming, as where secondary consciousness functions while dreaming. It's more like a hybrid state of the brain, which shows increased synchronized activation of frontal and posterior cortex of the brain. Areas of secondary consciousness are quite active during lucid dreaming. And it seems that some studies from 2009 have connected cognitive development and maybe intelligence to lucid dreaming. So the more of this, the more of lucid dreaming. You experience lucidity during REM and not during non-REM. And of course, during awakening. So it seems that lucidity while REM dreaming and while you're awake, you somehow experience similar states of consciousness. Much interest has been devoted in lucid dreaming. I personally believe that lucid dreaming is indeed hiding the secrets of consciousness on whichever level we want to think consciousness. There are, of course, certain technical difficulties in studying lucid dreaming. However, I believe that if we are able to break the code of lucid dreaming, then there's so much for us to learn from that. My today's presentation was inspired and largely informed from the work of Professor Walker and Professor Hobson, from additional studies as well. And hopefully you find it as interesting as I did. Thank you.
Thank you very much, Aristea. That was fascinating. Do you want to stop the screen share and we will start looking at some of the questions? A lot of questions have been coming in. I think to try to get through them, I'm going to group them a little bit and ask several little groups. Is that okay?
Yeah, certainly.
So to the questioners, I'm trying to keep an eye on the new ones coming in, but I will try and get through these in groups. So there were a couple of questions about sleep deprivation I thought were very interesting. So the first one was, if you're sleep deprived one night and sleep extra the next, do you catch up on sleep, reverse the effects?
That's a very interesting question. You do not catch up, unfortunately, on sleep generally, but you do catch up on REM sleep, and that's the interesting thing. So most of your sleep during the next night will be in an REM state, as opposed to regular sleeping, which involves, in adults, just very few parts of REM.
Great, thank you. And this is clearly a very personal one. What about sleep deprivation in mothers of new babies who cry through the night?
Oh my God, I know. I have 3 of them. So it's sleep deprivation and it influences your cognitive and emotional system, just like the studies say. At least I have experienced it like that. I don't know about you. You feel like you get used to that lower amount of sleep, and you have to get used to that. You cannot function otherwise, but you cannot avoid the negative influence on your cognitive and emotional system, unfortunately.
That is unfortunate, sir. So last on that was, you talked about sleep deprivation. Are there any effects of oversleeping?
I guess that your circadian cycle is influenced by oversleeping, because it seems that on average, for most human beings and for most mammals, actually, we need more or less like, say, 7 to 8 hours of sleep per 24, 25 hours. So since we seem to have evolved for that cycle, obviously any deviation from that could be harmful. However, I'm not aware of studies that have investigated any effects of oversleeping.
Yeah, not something we see a lot of in students. So while you're talking about cycles, there are a couple of interesting questions about cycles I thought I'd bring up. So first one was, is there a difference in the sleep cycle at different stages of life? Is REM and deep sleep different in teenagers, for example?
Mm-hmm. That's a very interesting question. As far as I know, what I know about REM and age and development is that the younger you are, the more REM you experience. So newborns experience a lot of REM. It's like about 50% of their sleeping is devoted to REM activity, which is far from the REM experiences that adults have. You can see that in puppies as well. If you ever had a puppy, you can see them, moving a lot while asleep, whereas that does not happen that much in older dogs. So REM is pretty valuable for them. As we said also, lucid dreaming is very evident until adolescence, until about 16 years old. But then both REM and lucid dreaming seem to start decreasing. Maybe we don't need them that much. And what happens cognitively until about the age of 16? Well, according to certain very well-supported theories, our cognitive development is full. It reaches its peak at about 16 years old, where you have developed all your cognitive and higher order complex cognitive abilities. So maybe REM is no longer needed that much, I assume.
That's really interesting. There's a kind of another sleep cycle question here. And this, I'm just going to give the punchline question. So the person who asked it, forgive me for not giving some of the details, but this was about the impact of dementia on sleep. Has anyone looked at the impact of dementia on sleep?
Yes, indeed they have. It seems that the tau protein, which is a characteristic, the accumulation of the tau protein characterizing Alzheimer's disease, increases when you are sleep deprived. And unfortunately, the circadian cycles of older adults get influenced a lot by reducing the amount of sleep that they experience. And this does seem to add a lot in developing at least Alzheimer's dementia.
Great, thank you. So I'm going to keep, we've got so many questions coming in. I'm going to keep moving this quite fast, but these are really useful answers. Thank you. There's a bunch of questions about the monitoring of sleep and the technologies around that. And the first one is one I've always wanted to ask. How do people manage to sleep during a very noisy MRI scan?
Well, there is a solution of listening to music while asleep. However, this would influence your brain activity. You can also experience the MRI noise as white noise and fall asleep. I personally have fallen asleep during an MRI, and it was quite a pleasant sleep because I wasn't thinking of anything. I was just listening to the noise going over and over again, and that was so calming. So that's experiencing it as white noise. So it seems that you can get participants, no matter how young they are, you can get them to get used of the MRI noise by getting them to listen to MRI sounds before they start participating in the study. So then they get used to it and they perceive it as white noise during the study.
Wow, impressive. I don't think I'd have ever fallen asleep when I've had an MRI. So another question was about the technologies. And a lot of people have these fitness watches which detect their sleep patterns or claim to. How do they do that?
Well, these could do that by detecting skin temperature, because temperature drops a bit when you start feeling that you need to go to sleep. This could be done also by measuring the time that elapsed from the time that you woke up, right? So this could happen, could use that information as well. And I guess what other sensors do these watches have?
They have motion, don't they? And
motion, right? But I'm not sure whether they could use motion to calculate, unless they derive an average of motions during every day. And then if they see extra motions, they tell you that, oh, you overdid that, you have to go to sleep. I don't know.
Yeah, but they're clever, but
yeah.
It's interesting. Thank you.
But hopefully we won't be so dependent on technology to realize when we want to fall asleep. We have our own ingenious mechanisms to do that. right?
Yeah, yeah. But maybe we learn a little bit about how we sleep during the night. Better. Couple of questions about EEG in different states. So one person's asked about what EEG looks like during hypnosis, and another about during meditation.
Very interesting questions. Well, both during hypnosis and meditation, we should experience more delta waves. The delta waves are the very lowest frequency waves, which are deeply penetrating, like a drum beat for your brain. So they're penetrating through all brain structures like that. Delta frequency is believed to suspend external awareness because of its very low frequency. And as I told you, it's also considered as the source of empathy because it helps you change your focus from yourself to the state of others. So since it signifies deep meditation, I expect that hypnosis is similar to that.
Great, thank you. Right, well, let's move on to dreams. We've got 6 minutes left, I think. So there's a load of questions that come in about dreaming. Inevitably, fascinating topic.
Yeah.
So first one is a question. As I'm sure you know, that historically dreams have been used in medical diagnosis, but whether that's not used so much now. But someone has asked, can dream diagnose a psychotic person? Can you diagnose psychosis with the dream?
Very interesting question. Back in the 50s, if I'm not mistaken, until the 50s, they used to believe that if your dreams are colorful instead of black and white, that's an indication of psychosis. I'm not sure why. Also, if we accept that in projective psychological tests, the tests that we use with an ambiguous picture, for example, and we ask the client, what do you see in that picture? In certain kinds of these tests, it is believed that if the client sees the internal organs, for example, that could be a sign, that seems to be a sign of psychosis. Similarly, some people have theorized in the long past that if you see blood, the internal organs, while dreaming, this could be a sign of psychosis. However, there is no solid evidence to support that. You can only diagnose psychosis when the person is fully awake, no dream brain waves to diagnose that. This would take us back in the past of phrenology, wouldn't it? So you need a proper clinical interview to do that.
That's great, thank you. And now a bunch of questions. I'm going to kind of all merge into one. Apologies to the questioners for this, but there are a bunch of questions about how dreams are constructed. So comment that sometimes dreams are very mundane about day-to-day things, and sometimes they're abstract and bizarre. A question referring to the psychoanalytic perspective, but saying, well, perhaps some dreams are not from some repressed or suppressed element experience. Could they have other causes?
Yes, of course.
I'll let you take those two for now.
Okay. Yes, of course they could. I mean, that's just one perspective, the psychoanalytic one. There are other perspectives supporting that dreams is an internal model of the waking world. And so that because of that high brain disinhibition while dreaming, so brain centers all active and stuff, you experience stimuli that are produced within. But how are those stimuli produced? You have experienced that stimuli while awake. You have saved them in your hard disk, and then they get reactivated while asleep. So about 20%, it seems that about 20% of the dream material is not related to reality. The rest seems to be related, at least from dream self-reports. Now, what was the first question?
So the first question was the bizarre, non-bizarre.
That bizarreness is supposed to be experienced because of that different brain state of gamma band, of complete, or not complete, but huge brain disinhibition, which does not happen during wakefulness. Chaos would be created if everyone experienced disinhibition while awake. So this could be a sign of using only one, the proto-consciousness, as we said, the primary consciousness, and not secondary. Maybe if we used only primary consciousness while awake, we would experience reality again as bizarre. Maybe newborns experience reality as bizarre as we experience dreams. But we cannot know that right now, at least.
Yes, and small children too, as one of my colleagues once pointed out. As far as small children are concerned, toys magically restore themselves to the toy box in the night.
They do, I swear.
Fascinating. So, yeah, we've got some other interesting questions here. So two questions.
Oh,
one
can you
is,
excuse me for a bit, please? Excuse me. Before. I'm back.
Thank you. So two more questions about things that happen in your dreams. So the first is, do you think we can only see things in dreams that we've experienced before? So here's and the second one is, do you think there is a scientific explanation for the common dreams that people seem to have, lots of different people seem to have, like losing teeth?
Very interesting questions, aren't they? So, no, you do not have to experience everything that you see in your dreams, certainly. Because as we said, 20% of dream material has not been experienced as far as we can know, right? So this is just material created from, we could say, stimuli that have been randomly combined while dreaming, right, due to brain activation. That's one theory. Another theory posits that maybe dreaming is the need of the brain to create prophetic, predictive scenarios of what will happen. So you have something concerning you, your experience, problem at work, problem with your spouse or whatever. So you dream something remotely related to that, or that it could be translated as related to that. The Hobson supports, for example, that these are predictive scenarios created by the brain to inform your brain library, so that in case that in reality you have to make a choice, you have to make a decision, you get informed by that scenario that if you take that decision, this will happen. Because the brain is a perfect probabilistic machine. This is how it works. So if you have those predictive scenarios, you have more opportunities. You have more opportunities to choose wisely, right?
Yeah.
So lots of theories about it.
That's really, really interesting. I'm going to end with one question, which I'd like to know the answer to. It's been asked a couple of times. So what do you think is the difference between dreaming and what people sometimes call sleep hallucinations, hypnagogic and hypnopompic hallucinations? Is there a difference between that and dreaming?
Okay, no, actually, those kinds of hallucinations are part of vivid dreaming. So dreaming is hallucination. Dreaming is a psychotic state. We must accept that.
Well, that's a good one to end on. We can all say thank you so much for this wonderful talk, and really, really engaging answers to the questions as well. We're all going to go away and worry about being psychotic in our sleep now. But thank you very much. And to the audience, just to tell you that this has been recorded and you'll be able to watch it again on the YouTube channel.
Thank you very much.
So thank you so much, Aristea. Fascinating talk, and you had lots of unanswered questions still to a really receptive audience. Thank you.